practiced, processed the Pythagorean theorem, how to prove that. Are you guys clear about how is Pythagorean theorem derived? Are you clear about it now?
Yeah. Oh, and also, by the way, I need to use the restroom real fast.
Sure.
Can I? Okay.
Yes, sure, sure. So Arna, uh, tell me how comfortable are you with the theorem? How it is
Yes,
derived? You're
I'm
clear?
good. Like it's like
Oh, easy. So always remember one thing, okay? So the base of Pythagorean theorem is, or Pythagoras theorem, whatever you call it, is that property of similar triangles, okay? And that is what derives this, okay? So after having understood, okay, am I sharing my screen so far? No. Okay, let me share my screen quickly. But hereafter also, whatever we learn, whatever we'll do, whatever formula we'll come across, we'll try proving that. Okay, so that way it you don't have to just do it because I'm saying so. Math is all about proving and then doing it. Okay, some of the formulas could be of nature where you will have to accept that this is a formula, because those can be proven when you're in the higher grade, when you deal with calculus and other complex math concepts. But yeah, most of things otherwise we should be able to prove it. Okay, so we'll wait for Mitran to come back and then we can resume the class. But anything that you worry about, any doubt you have, please feel free to ask me so that no I can try simplifying it. Okay. And as I've always told all my kids, right, that it's okay to make mistakes. It's okay to know something which is wrong. We can fix it. We just have to figure out what we know and what is not right. All right.
I'm
okay.
back.
Okay, cool. So I was asking Arna, also Mitran, if she is comfortable with how we have proved that Pythagorean theorem. So
Okay.
going forward, we should not have any doubt about why that theorem is in place and what does it mean to us, right?
Yeah.
And And if I can say the least about Pythagorean theorem, it is on the base of the properties of similar triangles. That's how we proved it. Correct?
Mm-hmm.
So if you know similar triangles, then the sides are in the same proportion, which are against the matching angles. And that's the base of the Pythagorean theorem. Okay.
Okay.
All right. So now, after doing so much of thing in last two classes, what we are learning is, if I'm talking about a right angle triangle, ABC, where the two adjacent sides are A and B, and hypotenuse is C, A square plus B square equals C square. Okay, that
Mm-hmm.
this is all about the Pythagorean theorem, and this is what we will use for doing a few sums in the upcoming classes, or actually as assignments. Now, let me give you guys few sums. I know, Mitra, you have done it. Arna might not have got a chance to do it because he missed one of the class, right? So let's look at this as right angle triangle. Okay, this is 5 centimeter. This is 12 centimeter. I want to know what is the length of this one. Who can tell me quickly and how you are deriving that?
Okay, get my notebook.
Yeah, sure. I want you both to try. If you are able to do it, wonderful. If not, I'm here. Don't worry. Anna, you got the question right?
What?
You got the question right?
Yeah.
Okay. Okay. I'm just trying to find out the hypotenuse of this right angle triangle. Okay. I know one side is 5 centimeter, other side is 12 centimeter.
I'm back.
Okay. Once you have finished it, let me know.
Okay. Wait, for the other side, is the other side 13?
Okay. Adna, what's your answer? Were you able to find it?
Sorry, I was on mute. Yeah, I also got that.
13. Okay. So can somebody explain me how did you do it?
I did like 5 times 12. Yeah, 5 times 12 and whatever, and then I multiplied it by something else to equal 90.
Okay. So here, uh, this is where we are using the Pythagorean theorem actually. Okay. So this is 5 centimeter. This is 12 centimeters. So this is A and this is B. What we are trying to find is C. Okay. So Pythagorean theorem says A square plus B square equals to C square. Uh, Let me know, Mitran, if I'm doing something different from what you have done. Okay.
Okay.
So this is A. Basically, A and B are two adjacent sides which are making 90-degree, right? In the Pythagorean theorem. So this is A, this is B. B is 12 centimeters, A is 5 centimeters. So A square is 5 centimeters square. 5 centimeters square. Plus B square is 12 centimeters square. Equals to C square. We are trying to find out C square. So here, 5 centimeters square is 25 centimeters. 5 to 5, 25, 25 centimeters square. Plus 12 centimeters square is 12 into 12, 144 centimeters square equal to C square. So 25 centimeters square plus 144 centimeters square equal to C square. Okay. So
Okay.
25 plus 144 is 169 centimeter square. So 25 centimeters square plus 144 centimeters square makes it 169 centimeters square equal to C square. Now keep this aside. This is centimeter square. So you can make it centimeter. Okay, fine. Let me do that square root thing here. So what we are getting is C square equal to 169 centimeter square. Okay. Let's park this for now. What is the value of 169? Can I write this as a square of something?
Square root of 169
Yeah, I'm
is
saying,
13.
yeah, 13 into 13 makes it 169. Okay, that's
Yeah.
what I'm saying. So that this is 13 square. 13 square centimeter square. If I do a square, so C square is 13 square centimeter square. So that means if I say C, it will be a square root of 13 square into centimeter square. 13 square centimeter square. So it will be 13 and 13 centimeter. Okay.
Okay.
So
Yeah.
same thing here. We are just applying the formulas. Now since we know the formula for a we know the Pythagorean theorem. It says A square, A and B, this is C. This says A square plus B square plus C is equal to C square. Here A and B are the two sides making the 90-degree angle, and C is the length of the hypotenuse. This is this one. There would be questions where they will give you one side and hypotenuse. You have to substitute the value, find it out. They'll give you two sides. They'll say, okay, find the hypotenuse, like what we did. So I'll give you guys some sums, and then you guys can try doing that to make sure that you're able to practice that enough. Okay,
Okay.
that's the Pythagorean theorem. Any question that you guys have here before I move on?
No.
No. Okay. Arna?
No.
No. Okay. And if there's a question, please feel free. Okay. I mean, if there's any doubt, there's something that you're not really clear about, please don't hesitate. Okay. That's what makes me happier as a teacher. Okay. All right. So before we move on, tell me what is that you guys are learning in your class right now, so that we can pick up that and get going with that, so that no, it catches up with your current thing that is happening in the class as well.
Okay, so what what we're learning in classes, we're learning about exponent and radical equations, and we're also simplifying them. That's what we're learning in class right now.
So exponents we have learned already.
And what about
We're, we're,
radicals?
Got it. Okay.
we're learning like volume, area, like
Okay.
that stuff.
Okay. So
Base, height.
okay. So volume and area that we have covered in the previous classes, correct? While we were doing geometry, is that
Yeah.
that is
Yeah.
that you're learning in addition to that that you would want me to explain, or what we have learned in the class so far that is enough based on whatever you guys have gone through so far?
Well, after we learn about Pythagorean theorem and exponent and radicals, after that we're going on spring break, and after spring break we're gonna do some like star review after spring break.
Okay, that means they're not going to do new thing. They're just going to kind of uh, catch up on the on whatever is taught so far, so that
Yeah,
you're ready for the start. Okay.
yeah, that's what my math teachers told us.
Mm-hmm. Okay. How about you, Arna?
Wait, so like,
It's a similar thing, right? That's what you're saying. So whatever is
yeah.
being taught, after that there'll be spring break, and then you guys will do a revision for or prep for the star test. Okay.
Yeah, we will.
So let's quickly check on the areas thing, okay? Area and volume thing, and see if you guys are missing something or that you need to know, right? So we learned about the area of triangle, rectangle, square, rhombus, trapezium,
Hmm.
trapezium, yeah,
Yeah,
rhombus. We learned the area of these shapes, right? Then the circle also, yeah. Then we looked at volume thing, right? Where we learned about the volume of cylinder.
yeah.
We learned about the volume of a cuboid.
Hmm.
Yeah.
Hmm.
Yeah.
We learned about the volume of a cube, relating that with ice cube. Yeah.
Yeah.
Then we learned about this cuboid is nothing but this is also called a rectangular prism, right? So that also we kind of learned. You can say so, right? Then did we learn the volume of a cone?
Um, well, at school they taught us the volume of cone, but I don't know if you taught us.
I don't think I taught
We haven't learned the volume cone.
you. You haven't learned it volume cone so far. Okay. So fine. So, what is a cone first of all? Cone is like a funnel, right? That you would have seen, right? When you have to you would have probably seen at home when when they pour a liquid into a bottle. They use a funnel, right? Which is um, like open shape, which has narrow thing towards the end, through which the liquid goes in the bottle, right? You would have seen something like this. Yeah. Or
Yeah.
let me show it like this. Yeah. Something like this, where this portion goes inside the bottle where you're trying to pour the liquid. Okay. So this gives you a view of what a cone looks like. Okay. But in geometric terms, in terms of geometry, this is what you call as a cone. Meaning, if you look at it from the side, it looks like a triangle. Okay. If you look at it from the top, it looks like a circle. Okay.
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 So let me try finding out an example for you guys, that I can show you how how a cone would look like. So you guys don't have the privilege of doing this. When we were small, when I was small rather, we used to get something in the train in a shape like this. Okay. It's I don't know what you call it. You both understand Hindi a little bit?
Yeah.
Hindi.
Arna knows.
Yeah, yeah. I understand a little bit of
Right.
Hindi.
Okay. So there's something we call it jhal muri. Okay. Jhalmuri is something that you get in even West Bengal or Orissa, right? When you go by the train, in the train, the hawkers will come. They will have the puffed rice with a lot of spices into it. That's what is called jhalmuri. Okay, so they used to make something like this, and they used to put that in this one. Okay, because they will not carry all the utensils, so they'll take a piece of paper and roll it like this, and fill this with the puffed rice and the all the mixtures into it. They used to call it jhalmuri. Okay. So this thing that you see, this symbolizes a cone. Okay. So this is not a perfect cone actually. I have to cut it here a little bit so that it looks like a circle when you see it from the top. Okay. And when you see it from this side, it look like a triangle. Okay. So this is not a perfect cone because I have not chosen the right piece of paper. But when you look at a perfect cone, this the page, I mean the sheet has to be better. This will look exactly like this. Okay, like the funnel that I was talking about. Okay, so if you look at it from the front, this will look like a triangle. Okay, if you look at it from the top, and it's not a perfect one, but if you look at it from the top, it will look like a circle. Okay, once it is made correctly. So that is what is a cone. Now let's try relating that with what we have learned so far. Imagine the shape that we learned here. It was called right cylinder. Okay, if this one was like this from here to here, this would have been cylinder, right cylinder, right, for which we figured out the volume is equal
Wait,
to.
Virendra, I need to get tissue. My nose is like full
Sure,
of mucus right now.
sure, that's okay. So Arna, if you remember, if I'm talking about a right cylinder, meaning a cylinder like this, which looked like a circle from here. Okay, and
Yeah.
so this is called cylinder, for which we figured out the volume is the pi r square h, where h is the height of the cylinder and pi r square, this r is the radius of the cylinder. Basically, this radius, this is a circle, the radius of this circle. Okay, so this is the height and this is the radius. So this will be pi r square h. That will be the volume. If you are dealing with a cone, okay, I will not be able to prove the formula why the volume of a cone is equal to one third of pi r square h. Why? Because this needs a little bit of knowledge of calculus, and I don't want to overwhelm you guys with the concepts of calculus. Okay, but for the sake of simplicity, if you want to remember this, volume of a cone will be one third of the volume of a cylinder with the same diameter. So let's say this is the height, this is this tall, right? Here to here, the height is this, and this is the radius r. So it will be one third of pi r square h, where r is the radius of the cone, meaning radius of the biggest circle that you see here. Uh, if this was a perfect circle, right? There was a radius for that circle, and this is the height from top to the base. So this volume of the same volume of the cone is one third of pi r square h. Okay. Volume of a cylinder is pi r square h, where no, if this was not a cone, if this was not, these two portions were not cut, okay, and this would have been just like a cone, like a shape like this, that would have been pi r square h. But cone's volume is one third of a volume of a cylinder. So so let's look at it side by side. I think then you'll be able to relate. Okay, this is the cylinder. What is the volume of this? We have learned it's pi r square h, where r is the radius and this h is the height. Okay. Now imagine a cone by the side of this, where the height is same from here to here. This height is h, and the radius, this radius r, is same as this radius. Okay. So the volume of this guy is one third of a volume of this guy, whatever volume you see here. Okay. How it is done? There's a way to do it, and for now, let's not worry about it, because this is something that we can prove by using calculus, and calculus is way too early for you guys in seventh grade, so I'll probably park it there.
Okay.
Mitran, are you back? No.
I
Okay.
don't think he's back yet.
Okay. So
I'm back.
here, okay. So Mitran, I was telling Anna about the volume of a cone. I was doing the comparison between a cylinder and a cone. Okay. So
Okay.
here, volume of a cone, volume of a cylinder is pi r square h, as we have learned. Volume of a cone is one third of the volume of a cylinder otherwise. So if this is the radius, the biggest radius of this cone, and this h is the perpendicular height, perpendicular distance between this point and this point, the volume of a cone is one third of pi r square h. Now you'll say, why do I trust you? I can prove this, but I will not. Primarily because this is something that you will learn. It'll be easy to digest when you guys learn calculus. And it's little too early for you guys to learn calculus. So that's why I'm just telling you that this is the formula for now. Once we learn calculus, we'll come back to this and we'll prove it. Okay.
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 But for the sake of simplicity, now you,
He just left the meeting.
okay. Oh, he'll come back. Okay. Wait, let's give him a minute. Okay. So here, look at the optics of it. Okay. So if you look at the cylinder and the cone is fitting somewhere here, right? You have one side here, one side here. So it's like, you are splitting this into three sides to get a cone, right? You are cutting this portion, this side and this side both. This portion, if you cut or trim, that is what gives you a cone. Okay. So for memorizing it, you see that, okay, you are cutting two sides of it and you are just using the central part of it. So you are cutting two sides and just using one third of it. So that is how one third of this one. Okay, that's how you can relate it. I mean, just for memorizing it better. Yeah. Okay. So is that okay to consider or not? So I'm just saying, if I have a cylinder, my volume will be pi r square h, where h is the height and r is the radius of the cylinder. My volume of a cone, okay, of a cone inside this will be one third of the volume. Just to memorize this, okay. So this is the height of the cone. I'm just drawing it inside this one. It's like like you would have seen a lot of decoration stuff which has a cone inside that, right? Like a funnel cut inside that. So this is like always one third of the overall volume of the cylinder. Yeah. Are you with me?
Yeah.
Okay.
Yeah, yeah.
Okay. Now tell me. So we have learned two-dimensional shapes. We have learned cuboid. We have learned cube. We have learned right cylinder. We learned this one also. We learned cone also just now. Tell me what else you have learned for, or what all. I mean, what extra has been taught to you in the class with the three-dimensional shapes? Anything that you would want me to explain or share?
No.
Okay,
Sorry, I left my screen blacked out, so I had to like close it and reopen it.
not a problem. So you can see my screen, right, Mithran?
Yeah, I can.
Okay, so basically, I was just checking what else you guys have learned in geometry apart from whatever we have done so far. So we have done two-dimensional shapes, triangles, quadrilateral, pentagon, hexagon, octagon, all the magical formula, the area of triangle, square, rectangle, rhombus, trapezium, right? Then we went on to three-dimensional things where we learned about the volume and surface area of cuboid, cube, cylinder, and today we learned about the volume of cone. So I was telling Arna that volume of a cone is always one third of the volume of a cylinder. So it's like you are cutting a piece from this. If you're talking about the cylinder, overall cylinder volume is pi r square h. When you're talking about volume of a cone, this piece, it's like you're cutting this into three equal pieces. So that is one third of pi r square h. Now I was asking, is there any other shape that you have learned in your geometry classes that we need to touch upon here?
Mm, well, those are just like the only shapes I learned. I learned about cylinder,
Hmm.
cube, rectangular prism, and I learned
Hmm.
about triangular prism, the area and the volume. Same with the all the other shapes, the hexagonal. Same with the other ones.
Okay.
We were just
So,
finding area and volume and surface area and lateral area for all of them.
correct, correct. So this pretty much aligns with what I have kind of explored and planned for you guys for geometry till eighth grade. But I was just checking if there's something that we are missing here. Okay, anything that is taught additional in addition to what is there on Khan Academy. Okay, all right.
Okay.
Now let's pick up the next topic. What is that we want to start? So I'm just checking the syllabus for you guys for level 2, which includes grade 6, 7, and 8. Okay. So, okay. All right. So, so we have something called rates and percentages, integers, addition and subtraction. That you guys would be knowing. Rational numbers, addition and subtractions. Negative numbers, multiplication, division, that you would know, expression, equation, and inequalities. Okay. So next thing is expression, equations, and inequalities. Are you guys familiar with that?
Yeah, we have learned about it.
Okay. How about statistics and okay, before you have learned about it, Mitran, let me ask the same thing to Arna also. Arna, have you learned it as well?
Wait, can you repeat the question?
Wait,
Have learned what?
Expressions, equations, and inequalities.
Yeah, we've learned that before.
You've done that. Okay. Now, then comes rational numbers, rational number arithmetic. Have you guys learned about the rational numbers?
yeah, we think we have learned about rational numbers.
Okay. So let's quickly touch upon that. So can somebody explain me what is a rational number here?
Irrational numbers like decimal numbers, fraction numbers, and all the other numbers in the downer section.
Sorry, say that again. One second, I see one more student in the class. Nav.
Oh, sorry. I think I joined the wrong class. I'm sorry. Let me one. Sorry.
That's okay. Okay. Yeah. So yeah, Mitran, you can go on.
So what I was talking about is a rational number is like I don't know the definitions, but I know the numbers. They're like decimals, decimal numbers,
Mhm.
fraction numbers, and all the other numbers, all the whole numbers, the integer numbers, and the natural numbers. That's what I remember.
Okay. So let me do one thing. Let's spend the next 15 minutes to quickly touch upon the different number types. Okay. We have only 15 minutes, so we'll touch upon the number types. We'll talk about the rational numbers. We'll talk about the fractions, decimals, and some basic stuff. And then in the next class, we'll look at. Um, I'm planning to do this one. It is. Let's do probability. Have you guys learned probability as well?
Yeah.
Okay, probability and sampling. Okay, fine. So fine. So what we can do is we'll do two things. Next topic will be probability and sampling and data modeling, data and modeling. Okay.
Oh, okay.
So the main purpose of that is to see all that we will do as part of probability and sampling as well as data modeling. These are nothing new. It's part of the concept that we have learned, but it gives a different dimension to our understanding of mathematics. Meaning, when you talk about numbers or any operations, we know what it is. But when it comes to data modeling, it gives a different view to how you look at the information that you have, and then you make some meaningful interpretation from it. Okay. So that is where we'll talk about the graphs, the bar chart, pie chart, whatnot. Okay. Those might sound very complicated, but it just makes it even simpler. Okay. So we'll talk about that. All right.
Hmm.
And then after that, we'll probably jump on to the equations, inequalities, and this one more time, so that from there we can move on to the graphs and other stuff also. Okay. All right.
Yeah.
So let's play with the numbers. Okay. So next 15 minutes are going to be fun. Now let's see. These are the baby stuff. Okay. But problem is we don't go back and kind of do a recap of what we have already learned. Okay. So let's see if you guys know it. If I have these numbers, so on and so forth, what are these called?
These are called whole numbers.
No, these are called natural numbers.
These are called
Oh,
not.
but I
That's what
thought,
I see.
yeah, but I thought natural numbers would have zero included.
It's the other way around, right, Arna?
What?
If you have only 1, 2, 3, 4, 5, 6, so on and so forth, these are called natural numbers. If you
Yeah.
put a zero to it, this set becomes whole number.
Oh.
And if you add -1, -2, -3, so on and so forth to the same list, okay, that
It'll
is
be integers.
integers. Yeah, you both are on the same page.
Yeah.
See, that's why I was saying that this might sound like a baby stuff, but we don't revise those, right? So that's where we end up, for this thing. Okay. Now, let's look at. Okay, if these numbers, come on, what are these numbers called? 1/2, or 1, or 2/2, 3/2, 4/2, 5/2, 6/2. What are these called?
Um, rational numbers.
fraction numbers. If you These are called fractions, fractional numbers. Okay.
Mm-hmm.
Now, if I put minus 1 by 2, minus 2 by 2, minus 3 by 2, that is when it is as a whole called rational numbers. Okay. The rational numbers are analogous to integers, incomplete numbers. Okay. Like we said, 1, 2, 3, 4 is called natural number. If you add a zero, becomes whole number. If you add negatives, it becomes integers, right?
Mm-hmm.
If same way, if you look at 1 by 2, 2 by 2, 3 by 2, 4 by 2, so on and so forth, these are called fractions. When you add the negative fractions also into it, this list, okay, this is when it is called rational numbers. Am I am i making sense? Am I teaching you something wrong? What do you think?
No,
This
that
is fine.
makes sense.
Yeah, this is
Yeah,
fine.
makes sense.
Yeah, yeah. So basically, rational numbers and integers are analogous stuff. Okay, they represent similar message. Integers talk with respect to numbers which are complete, without decimals, without fractions. When you're dealing with fractions, that is when you look at the comprehensive list with including negatives, it's called rational numbers. Okay. Now let's look at some more interesting stuff. Again, you guys will laugh at me, but that's okay. So if I have a fraction, I can convert that to a decimal also. Or if I have a decimal, I can convert that to a fraction also. Do you guys know how to do it?
Yeah, we do.
Okay. So what will be the value of this in fraction?
It would.
Yeah, go ahead.
Would it be like 13 over 50?
No.
Wait, wait, let me go check again. Wait. Would it be like 13 over 25?
Okay. So again, here I don't know if you have learned it this way or some other way. It'll be I have to convert this into a fraction. So what I will do is I will write whatever is there without a decimal. Okay. I'll just write this. Then I will put a 1 for decimal. Okay.
Mm-hmm.
No, I put a dot here. Huh. So now I will put a 1 for a decimal because I removed the decimal, right? I'm saying 0.52 equals to 52. That is not correct. I have to put the equivalent value. 1 for a decimal, and then I have to count how many digits I have. 1, 2. I'll put two zeros. So that is how it becomes 52 by 100. Because 0 before 52 doesn't have any meaning, so we can knock it off. Now you can simplify this. 52 is 13 into 4. 100 is 25 into 4. You can do tic tac toe, 4 and 4 gone. That is become 30 by 25. But always, if I have any digit, any decimal number, and I have to convert that to a fraction, I will just write the number as is, assuming there is no decimal, and then put a 1 for the decimal, and then count the digits. I have 1, 2, 3. So I'll put three zeros. Now it's up to us. How do we simplify this? Okay. This is the approach. This is the simplest approach. Okay. When you have a decimal, very simple. 39. I'll just write the number, put a 1 for decimal, count the digits. 1, 2, done. Okay.
Mm-hmm.
Is this something that you had done before, or is this something as a new approach
I think that's something we have done before.
you have done before? Okay. So I was just
Yeah,
doing a
we've
recap
done
on that.
this too.
I'm sorry.
We've done the same thing.
You have done the same thing. Yeah. I mean, because no, different places, the same thing is taught in different ways. So I was just trying to see if you guys are comfortable with this one. Now, let's do one more thing. Somebody says divide this by 8 by 10. How do you do it?
You keep the 1/5. You change the division sign to a multiplication sign, and then flip the 8 by 10 over to a 10 by 8.
Yes. So yeah, I'm just doing a recap so that now once we go to the algebra part of it, it'll be much easier for us. Okay. So I call it division makes you dance. So when you're trying to do division with fractions, it makes things dance. So this is where the dance happened. This guy flipped, did a somersault. This went up, this guy came down. That's what happens. So you convert a division to a multiplication and then the dance happens. This is how I, kind of tell kids to remember this. So, anyways, you guys know this. I'm just doing a recap so that no, when it just helps us to be up to date with what we are going to do next in algebra, probability, and data science. Not data science, data modeling, basically. Okay. All right. So I will give you guys some more assignments, which will be more related to volume and surface area, whatever we have learned. Uh,
Okay.
few sums related to the Pythagorean theorem that we have learned. Okay. I will not ask you guys to prove it, but whenever you get time, just try to recollect how we have proved it so that tomorrow, if you have to explain the same thing to anybody, you will not go blindly and say that, okay, Pythagorean theorem is this, you apply the formula into it. You can also say, I can tell you how this formula is derived because math is all about doing it by yourself rather than trusting anybody. Okay. No matter how
Okay.
good your teacher is. Yeah.
Mhm.
So that brings us to the end of the class. I don't want to start a new thing when we have less time left, and then no, we end up kind of not covering it completely. But I'm just giving you guys a prelude of